I built this CNC router about 15 years ago, and it's worked really well for me. It cuts accurately, and it's been consistently reliable. I've known for a while now that my Z-axis vibrates a bit, mostly when moving down. But I've ignored it until now, because I never hear it when the machine is actually cutting real parts. In this video, I adjust my microstepping settings to smooth out axis motion. But that subtle tweak revealed more than I expected. This is the first in a short series of upgrades I've wanted to make to my CNC machine for a while. Not because it doesn't work well, but because I've reached a point where refinement matters to me. Some of the changes are about performance, others are about reliability, convenience, or making everyday use even smoother. Nothing here is sponsored, and I'm not upgrading just for the sake of it. Every change solves a real limitation I've run into, or makes the machine more productive. I'll be tackling one upgrade at a time. Things like a water-cooled spindle, replacing worn-out limit switches, automating dust collection, and controlling the spindle and the cooling pump through Mach 3. And in each video, I'll share why it matters, and whether it actually improves real-world use. This first episode is specifically about motion smoothness. More accurately, it's about unlocking performance that already exists in the UC100 controller that I've been using, but I've never really taken full advantage of it. This isn't about buying new hardware. It's about understanding and using what I already have to its fullest potential. I originally installed the UC100 when I was trying to transfer my CNC machine from Windows XP to Windows 10. That transition never really worked out. And Mach 3 on Windows XP ended up being the most reliable setup for me on this machine. So I ended up leaving the UC100 on the machine more or less as a glorified parallel port. What I didn't do at that time was revisit the configuration. I traded the UC100 as a replacement for a printer cable on my parallel port, rather than a controller with different motion characteristics. In hindsight, that meant I was probably leaving a lot of capability on the table, especially in how step pulses are generated and timed. To make these changes, I have to get into the electronics cabinet, and that's not an easy process. Any motion-related adjustment means opening everything up and getting into this tight space. I packed everything into this old PC cabinet, and I think I did a pretty good job. It looks good to me. It's functional, it's held up for years, but nothing about it is quick access. Since I'm already in here, I'm also documenting the connections, how many inputs and outputs I have left to make use of for my future projects. None of that is necessary for the changes I'm making today, but it'll help me when I want to do the future upgrades. What you're seeing here is how the UC100 is currently driving the stepper motors. Up to now, I've been running this system the way it was set up when I was running it on parallel port. That isn't necessarily wrong, but the settings are conservative from what they could be and emphasize reliability over smoothness. I'm changing the step-related settings to better match what the UC100 is capable of without changing motors, drivers, mechanics, or G-code. However, I do acknowledge that refining my G-code is also a great place to bring out smoothness in machine operations. So specifically, I've been running quarter microstepping, and I'm going to change that to 16th microstepping. That increases the resolution available by about 4 times. That'll have particular impact during acceleration, deceleration, and short segment moves. The goal here isn't so much to increase accuracy. The machine was already accurate. The goal is smoother motion and less excitation of mechanical resonances. This isn't a hardware upgrade, it's a configuration change. Making this change requires physically switching the microstep settings on the drivers. Before making any changes, I'm running a baseline test. I'll use the same file, the same feeds and speeds, and the same camera and microphone position for the before and after tests. The only variable will be the microstepping settings. I'm not expecting dramatic differences necessarily, but it'll be interesting to see how it behaves. I'll be watching and listening to see if there's any difference in how the machine behaves during direction changes and transitions where smoothness matters most. I also placed a bowl of water on the machine bed. This isn't meant to be a precise measurement. I just thought it might give us a visual reference of how much vibration is happening. With the drivers set to 16th microstepping, I'm running the exact same code again under the exact same conditions. The improvement from the microstepping change is subtle, and definitely smaller than I'd hoped for, but it's there. The motors sound a bit smoother now, and the motion feels just a little bit less jerky to me. But that god-awful noise from the Z-axis, well, that's still there. I think it's caused by a little bit of play in the lead screw when it's reversing direction. And gravity's not doing me any favors either. It wasn't my original plan to tackle this vibration, but I think I should, especially with a much heavier water-cooled spindle getting installed soon. So I'm going to test a hydraulic dampener. Hopefully it will provide some resistance when it's moving down and add a little bit of lift when the spindle's coming back up. But that will be the focus of the next upgrade in our series. And this is what happens when CNC fever kicks in. One upgrade leads to another. Thanks for watching. I hope this was helpful for you, and I'll see you in the next one.